Hello and welcome back to our exciting series on the Claisen condensation. And today we're going to look, this evening, we're going to look at the crossed Claisen. Okay, so earlier we saw a crossed aldol reaction, and we're going to do something similar here, only it's going to be a Claisen reaction. And what's generally recommended for a cross Claisen, like the crossed aldol, is you want to have a reactant that does not have an alpha hydrogen. Okay, and only it's a Claisen, so we're looking for esters here. Okay, and so here's some kind of usual suspects. Okay, so and you may notice I've done a mixture of ethyl and methyl esters, ethyl, methyl, and that's because that's usually what we use in reactions in Orgo 2 involving Claisen condensation. So, so we could have ethyl benzoate. So note there's no alpha hydrogen at our alpha position. We've got an alpha carbon, but there's no hydrogen on it. There's no alpha carbons in methyl formate. Here we have dimethyl carbonate. Again, no alpha carbons and no alpha hydrogens. And then we can have diethyl oxalate here. So the diethyl ester of oxalic acid. And again, there's no alpha hydrogens. There's a carbon in an alpha position, an oxygen in an alpha position. Okay, so these are good for cross Claisen reactions. So let's look at an example of using some of these in a cross Claisen. And I don't know if I mentioned this, but if I feel myself tripping over something in this video, it's all in the name of good lighting. I don't know if this is going to be any better, but keeps me entertained too. So, all right. So let's do a Claisen reaction. Okay. All right. Okay, so this is an ester. All right. This ester has an alpha hydrogen. So if I want to do a cross Claisen, I better choose an ester to go along with it that does not have an alpha hydrogen. Okay, let me try to remember what those choices were on the previous page. Okay. Oh, that's not an ester. That's an aldehyde. I gotta go back and review my functional groups. Okay, there's an ester. All right, so what are my conditions? What base am I going to use? Say sodium methoxide. We have an ethyl ester here, so sodium ethoxide. And then we're going to have a second step that's H3O+. Okay. All right. Oh, where'd my... Yes, there's my green pen. Okay. So what am I going to make in this? Okay. There's the carbon that has alpha hydrogens. Okay, that's going to form a bond to this carbonyl carbon. All right. Whoa. Oh, here I go. Not intentionally. I'm just not paying attention to where I'm stepping here. All right. There we go. Voila, there's my product plus ethanol. Okay. And you can see I've made a beta keto ester. Okay, with the cross Claisen. That was fun. Okay. Let's try another one. All right. going to use a methyl ester here. All right, and let's, any recommendations? Let's use dimethyl. Oxalate. I've got methyl esters here, so I'm going to use sodium methoxide and water, H3O+. Okay. Again, I want to identify where my alpha hydrogens are, and I've got a carbonyl carbon. Okay. So we're going to make a bond between these two carbons. Green. Okay. All right, and we want to remember we're gonna. Okay. We're gonna lose that methoxide as a leaving group, so we're making a bond between these two, and. So let me number this. I don't know if you can see any. Well, so this oxygen is that oxygen. This carbonyl is that one. And then this carbonyl is that one. Okay? All right. And I think I'm going to stop there. So this is going to conclude our video on across Claisen condensations. So thank you for watching.